Chapter 3, Working with Formulas and Functions Tutorial 3.1 Introduction to Formulas and Functions. Understanding the difference between formulas and functions. Formulas. Formulas in Excel are expressions that perform calculations on data in your spreadsheet. They typically start with an equals sign, equal symbol, and can include mathematical operations, cell references, and functions. For example, equals A1 plus B1 is a formula that adds the values in cells A1 and B1. Functions. Functions in Excel are pre-built formulas designed to perform specific tasks or calculations. Functions are like ready-made tools that you can use by providing them with specific arguments or inputs. Functions have a predefined syntax and are entered with parentheses, e.g., equals sum A1 A10, uses the sum function to add values in the range A1 A10. When to use formulas and functions. Formulas. Use formulas when you need to perform customized or specific calculations that are not covered by built-in functions. Formulas are ideal when you want to create calculations using operators, plus, dash, asterisk, /, perform comparisons, or create logical expressions. For example, if you want to calculate the average of a range of numbers, you might use a formula like equals sum A1 A10 / count A1 A10 to find the average of values in cells A1 through A10. Functions. Use functions when you need to perform common or specialized calculations efficiently. Excel has a wide range of functions for various purposes, such as sum, average, max, min, if, VLOOKUP, and many more. Functions are designed to simplify complex calculations and reduce the risk of errors. For example, instead of writing a formula to add a range of numbers, you can use the sum function, as in equals sum A1 A10, which is more concise and less prone to mistakes. Knowing when to use formulas and when to use functions depends on the specific task you're trying to accomplish. Formulas provide flexibility for custom calculations, while functions offer efficiency and accuracy for common and specialized tasks. Understanding the distinction between the two is essential for effective Excel usage, as it helps you choose the right tool for each job and work more efficiently. 3.2 Common Functions. Using common functions. Sum function. The sum function is used to add up a range of numbers or cells. Syntax, equals sum, number 1, number 2. Example, to calculate the sum of numbers in cells A1 through A5, you would use equals sum, A1 A5. Average function. The average function calculates the average, arithmetic mean, of a range of numbers. Syntax, equals average, number 1, number 2. Example, to find the average of numbers in cells B1 through B10, you would use equals average, B1, B10. Max function. The max function returns the largest number from a range. Syntax, equals max, number 1, number 2. Example, to find the maximum value in cells C1 through C8, you would use equals max, C1, C8. Min function. The min function returns the smallest number from a range. Syntax, equals min, number 1, number 2. Example, to find the minimum value in cells D1 through D7, you would use equals min, D1, D7. Count function. The count function counts the number of cells in a range that contain numbers. Syntax, equals count, value 1, value 2. Example, to count the number of non-empty cells in the range E1 through E9, you would use equals count, E1, E9. Practical examples. Calculating total expenses. Suppose you have a list of monthly expenses in cells A1 to A12. To calculate the total expenses for the year, you can use equals sum A1 A12. Finding the average test score. If you have test scores in cells B1 to B20, you can find the average score using equals average B1 B20. Determining the highest sales figure. In a sales report with monthly sales data in cells C1 to C12, you can identify the highest monthly sales with equals max, C1, C12. Identifying the lowest inventory level. In an inventory sheet with quantities in cells D1 to D10, you can find the lowest inventory level with equals min, D1, D10. Counting the number of customers. If you have a list of customer IDs in cells E1 to E100, you can count the number of customers with equals count, E1, E100. These practical examples demonstrate how to use common Excel functions to perform various calculations and data analysis tasks efficiently. Excel functions are versatile tools that simplify complex operations and help you gain insights from your data. 3.3 Logical functions. Introduction to logical functions. If function. The if function allows you to perform conditional tests and make decisions based on those conditions. Syntax equals if, logical underscore test, value underscore if underscore true, value underscore if underscore false. Example. If you want to calculate a bonus for salespeople based on their monthly sales, you can use equals if, B2 greater than 10,000, 500, 0. This formula checks if the sales amount in cell B2 is greater than 10,000. If true, it assigns a $500 bonus, otherwise, it assigns 0. And function. The AND function tests multiple conditions and returns true if all conditions are met. Syntax equals AND, condition 1, condition 2. Example, you can use equals and A1 greater than 18, B1 equals yes, to check if both conditions in cells A1, age, and B1, has driver's license, are true. OR function. The OR function tests multiple conditions and returns true if at least one condition is met. Syntax equals OR, condition 1, condition 2. Example, to check if a student is eligible for a scholarship, you can use equals or C1 greater than 90, D1 equals yes. This formula checks if either the score in cell C1 is greater than 90 or if cell D1 indicates extracurricular activities. Logical functions are essential for creating dynamic and responsive spreadsheets that adapt to changing data and criteria. They allow you to automate decision-making processes, making your Excel sheets more intelligent and useful. 3.4 Advanced functions. Exploring VLOOKUP and LOOKUP functions. VLOOKUP function. The VLOOKUP, vertical lookup, function searches for a value in the first column of a table and returns a corresponding value from a specified column. Syntax equals VLOOKUP, lookup underscore value, table underscore array, call underscore index underscore number, range underscore lookup. Example, suppose you have a table of products in columns A and B and want to look up the price of a product by its name. You can use equals VLOOKUP, product name A1 B10 2 false. LOOKUP function. The LOOKUP, horizontal lookup, function is similar to VLOOKUP but searches for a value in the first row of a table and returns a corresponding value from a specified row. Syntax equals lookup, lookup underscore value, table underscore array, row underscore index underscore number, range underscore lookup. Example, if you have a table of sales data with products in the first row and want to find the sales of a specific product, you can use equals lookup, product name A1 H10 3 false. Understanding the index and match combination. Index function. The index function returns the value of a cell in a specific row and column of a given range. Syntax equals index, array, row underscore number, column underscore number. Example, to retrieve the value from the intersection of row 3 and column 2 in a data table, you can use equals index A1 D10 3 2. Match function. The match function searches for a specified value in a range and returns its relative position. Syntax equals match, lookup underscore value, lookup underscore array, match underscore type. Example, if you want to find the position of item X in a list, you can use equals match, item X, A1 A10 0. The combination of index and match is powerful for advanced lookups because it allows you to perform more flexible and dynamic searches, including vertical and horizontal lookups. Advanced functions like VLOOKUP, lookup, index, and match can significantly enhance your ability to work with data in Excel. They allow you to perform complex lookups, data retrieval, and dynamic analysis, making Excel a valuable tool for tasks ranging from data management to financial modeling. 3.5 Relative and Absolute Cell References. Importance of cell referencing. In Excel, cell referencing is crucial because it allows you to create dynamic formulas and functions that can adapt to changes in your spreadsheet. Without proper referencing, your calculations and data analysis would be static and impractical for large datasets. Using relative and absolute references in formulas. Relative references. When you create a formula using relative references, Excel adjusts the reference as you copy the formula to different cells. If you move a formula with relative references one cell down or to the right, the references will change accordingly. For example, if you have the formula equals A1 plus B1 in cell C1 and you copy it to cell C2, it will become equals A2 plus B2 because the references are relative to the current cell. Absolute references. Absolute references, on the other hand, do not change when you copy the formula. You indicate an absolute reference by adding a dollar symbol before the column letter, row number, or both in the reference. For example, if you have the formula equals $A$1 plus $B$1 in cell C1 and you copy it to cell C2, it will remain equals $A$1 plus $B$1. Demonstrating when to use each type. Use relative references. When you want the formula to adapt and calculate based on the relative position of cells. For example, when performing calculations on adjacent cells, relative references are usually suitable. Example, calculating the total cost of items in a shopping list where the price and quantity are in adjacent columns. A formula like equals D2 asterisk E2 can be copied down to calculate the total cost for each item. Use absolute references. When you want to lock a specific cell or range so that it doesn't change when you copy the formula. This is particularly useful when you're referencing a constant value, a fixed cell, or a table header. Example, creating a formula to calculate tax for a set tax rate in cell A1 applied to values in cells B1 to B10. You would use a formula like equals $A$1 asterisk B1 to ensure that the tax rate in cell A1 doesn't change as you copy it down to calculate tax for different items. Mixed references, combination of relative and absolute. Sometimes, you might want to have a mix of relative and absolute references in a formula. You can achieve this by selectively adding dollar symbols to certain parts of the reference. Example, when building a summary table that references data in multiple columns with different tax rates, you might use a formula like equals $A$1 asterisk B2 where the tax rate is absolute, but the item quantity, B2, is relative. Understanding when to use relative and absolute references is essential for creating accurate and dynamic spreadsheets. Relative references are typically used for calculations that change relative to the position of the formula, while absolute references are used when you want to lock a specific cell or value. Mixed references provide flexibility for various scenarios. The choice depends on the specific requirements of your spreadsheet and calculations. Congratulations on reaching the end of Chapter 3 in our Excel journey. In Chapter 4, we'll be delving into pivot tables, the master tool for data manipulation and visualization. Get ready to turn raw data into meaningful insights.